Example number 3. So we're going to go ahead and use the power rule. The power rule. Guess I'm having trouble saying that today. And we're going to go ahead and squaring a binomial now. Okay, so it gets just a tad bit more hairy, but nothing that we can't handle because we're in the NFL. There's for life. Okay, so let's go and solve for x. Okay, and so since we have a radical here, we want to do the opposite of square root. So the opposite of square root is squaring. So I'm going to square both sides. Okay, and I got to put this side in parentheses because I'm not just going to square the 1. I got to square the whole thing, x plus 1 squared. All right, so that square crosses out with that square root. So we have nicely 5 minus x. That's cool. But then we have to do this, x plus 1 squared. Okay, so remember, x plus 1 squared does not equal x squared plus 1 squared. No! Okay, the square means I take the binomial and I have to multiply it by itself twice. X plus 1 times x plus 1. That's what that means. Okay, so by using our FOIL method again, oh yeah, FOIL all day long. So x times x is x squared. All right, so I just did this guy right here. And then x times 1 is plus x. And then 1 times x is plus x, and 1 times 1 plus 1. Okay, so notice that we can combine those terms together, and I get x squared plus 2x plus 1. So that means that's what this whole thing becomes. It becomes x squared plus 2x plus 1. Okay, so we're trying to solve for x now, right? All right, so the way that these guys work now, and you learned this from last class, is if we're trying to solve for x and we have a squared term in here, okay, we are more than likely going to have to solve by factoring now. Okay, so what we need to do is we need to move all of our terms to the same side as the x squared. So I'm going to go ahead and add x to both sides. Add x, add x. So that means I get 5 equals x squared plus 3x plus 1. But then I also have to move the 5 over here. So I'm going to subtract 5 from both sides. So those are gone. So I get 0 equals x squared plus 3x minus quattro. Okay, so now it's in what we call ready to be factored form now, where all the terms are on the same side. Okay, so now we're going to have to factor this. So this is review from what you learned from last class. If we're going to factor this, there's all kinds of ways to do this. I like to use what I call the Judo Method. Judo Method. Oops. You say, what the heck is the Judo Method? Well, you're not going to find that name in the book there. It's kind of like what I made it up. But the reason why I call it the Judo Method is because Mr. Wasabi came and he was like, what the? And did a Judo X. And basically, we put the last number on top, -4 on top, and put the middle number on the bottom. And so now we have a little math game now. We're trying to figure out these two numbers right here. And we're trying to figure out what two numbers multiply and give us the top. Okay, so we want to multiply and get the top, and we want to add to get the bottom. So two numbers that multiply and give us -4, and you add to get the bottom. Well, let's see. 4 and 1 will give us 4 and 3, but we want a -4 on top and a +3 on the bottom. So that would be like this. -1. 4 times -1 is -4. 4 plus -1 is a +3. So these right here are our two factors, meaning, look here, 0 equals x plus 4, and this is our second factor, x minus 1. Now the reason why we want to factor it, because now we set each factor equal to 0. So I set this guy equal to 0, and I set this guy equal to 0. So I have x plus 4 equals 0, and then I have x minus 1 equals 0. And now all I do is just go and solve for x. So I'm going to subtract 4. So x equals -4. And I'm going to add 1. So I get x equals 1. Okay, but the problem though is this. We don't know both of these answers are correct. Or if one of them is correct, maybe both of them are. We don't know. So we're going to have to check our answers. No, mijo, it's so long. Yes, I know this is pretty long now because you would like it to be done. But yeah, we want to go ahead now and check our answers. Okay, so what we're going to do here is, first of all, we're going to rewrite the original problem. So we have the square root of 5 minus x equals x plus 1. Okay, so there's the original problem right there. And maybe I'll just kind of just drag this guy down here. So this is this guy right here. Okay, and we want to go ahead and check our answer. So we want to check yo answer. All right, we want to check both answers. Maybe both are correct. Maybe both are incorrect. One's correct, maybe one's wrong. Who knows? All right, so let's check -4. So let's see if this is true or not. Is the square root of 5 minus, now watch this now, -4. Because -4 is the x. So 5 minus -4, is that equal to -4 plus 1? So is that true or is that false? Let's see here. 5 plus 4, right? Because 5, a double negative, is 4 right here. So that's the square root of 9, which is equal to -4 plus 1 is -3. So square root of 9 is 3, and the right side is -3. Is 3 the same as -3? Are they both the same? Nope. Nope. So that means we say that's false right there. So that one's done. So this one right here is false. Okay, now let's check our other one now. Square root of 5 minus x is equal to x plus 1. Let's go ahead and check 1. Okay, let's go ahead and plug in 1 and see what happens. Is it true or false that 5 minus 1, is that equal to 1 plus 1? Well, no, let's go ahead and find out here. 5 minus 1 is 4, right? So that's square root of 4 equal to 2. And square root of 4 is 2 equals to 2. Wha-bam! It is true. Ding! Happy faces. Woo! There goes little Billy. And he's raising his hands. He's like, I can't believe this. And we are done with that guy.